Hey everyone, it's Justin again. In this lesson, we're going to be learning how to graph circles from their standard form equation. By the end of this lesson, you will be able to graph a circle on the coordinate plane when given its equation in standard form. First, we'll learn the standard form equation for circles. Then, we'll complete 4 example problems. Think way back to Algebra 1. Do you remember learning about lines in the coordinate plane? There are 3 common forms of linear equations: standard form, slope-intercept form, and point-slope form. These are all different ways of expressing the same line, and they're all useful because they make certain information easier to find. Circles, although they're definitely not straight lines, also have different equation forms. There is standard form, which looks like this, and general form, which looks like this. In this lesson, as well as the next one, we're going to be talking about standard form. We'll talk about general form later on in this unit. So for now, let's just focus in on standard form. In this equation, x and y just represents the x and y coordinates of points in the coordinate plane. In standard form, these will stay x and y, and they won't be replaced. Let's talk about h and k next. Together, these represent the coordinates of the center of the circle. Notice that h is the x coordinate, and it's next to x in the equation. And likewise, k is the y coordinate, and it's next to y. That's a great way to remember which coordinate is which. Lastly, we have r. Take a guess. What do you think r might represent in the context of circles? Did you guess that r stands for radius? Nice job making connections to some of the previous formulas you've learned. Notice here that this term is r squared, but the radius is just r. This is going to be important. Let's take a look at this formula in some examples to help solidify what all of these different pieces mean. Here's our first example problem. We need to graph the circle represented by the equation. It's going to be helpful to bring in our standard form equation so that we can compare all of the components here. So what's h in the bottom equation? H is subtracted from x, so it's 1. What about k? K is subtracted from y, so it's 3. Lastly, what's r? We can solve this little equation by taking the square root of both sides to see that r, or the radius, is 3. Let's start putting this together. Remember that h, k represents the center of the circle. What point will be the center of this circle? Well, since h is 1 and k is 3, the center is at 1, 3. Let's plot that on our graph. We need to draw the circle around this point with a radius of 3. The most straightforward way to do that is to just find the points directly horizontal and vertical from the center. Since our radius was 3, we can go 3 units to the right of the center and plot 1 point here. Now we'll go back to the center and repeat, this time going 3 units straight up from the center, and I'll plot another point. We'll do it again, this time going 3 units straight down, and finally we'll go 3 units left of the center. Now we have 4 points on the circle, so we can see the shape forming a bit. All that's left is to just connect them all in one big circle. Is the center part of the circle? It's actually not. It's just the point equidistant from all of the points that are on the circle. So we should just erase this or lighten it when we're done. All right, let's do another. We have the same problem, but with a new equation. Let's bring back up the standard form equation. We also know that we need to look for h, k, and r. Before you jump in, though, I want to point something out. The standard form equation has x minus h and y minus k. But our equation has x plus 2 and y plus 4. What do you think this means for our values of h and k? In this equation, h is negative 2 and k is negative 4. We can see this by rewriting each of these expressions using subtraction. Since adding is the same as subtracting a negative, we can rewrite this equation as x minus negative 2 squared plus y minus negative 4 squared equals 4. Always double check that your h and k values are what is being subtracted from x and y. Now that we have h and k, what is the center for this circle? Since the center is h comma k, that will be negative 2 comma negative 4. There's one more thing that we need. What's r, the radius for our circle? Did you say 2? We can see that r squared is 4, and if we solve, that makes r equals 2. So, we need to graph a circle with a radius of 2 whose center is at negative 2 comma negative 4. Why don't you pause the video now and graph this for yourself? First, you should place your center. From here, you'll want to plot the points that are 2 units directly to the right of the center, 2 units directly above the center, 2 units below the center, and 2 units to the left of the center. Now we can connect them all with a circle. Lastly, I need to erase or lighten my center point since it's not actually part of the circle itself. Repetition is the key to mastery, so let's keep going. Here's a new equation. Pause the video here and try this one on your own. You'll need your center and your radius before you can graph it. Did you find that h is positive 1 and k is negative 2? Don't forget to check your operations compared to standard form. Since the equation has y plus 2, that makes k negative, and this gives us a center point of 1 comma negative 2. For the radius, well, we can see that r squared is 20. That means the radius is the square root of 20. That is not a nice whole number. It's not going to be possible to graph this perfectly since it's an irrational number, but we can use the decimal approximation to do our best. You put the square root of 20 into a calculator, what's the decimal approximation? Your calculator should give you 4.7214. And since we have to graph this by hand, we can just round and say that the radius is about 4.5. If you weren't able to graph the circle before, pause the video here and try to finish it off on your own. Your center should be plotted here at 1 comma negative 2. Then we can plot the points that are about 4.5 units to the right of the center, above the center, below the center, and to the left of the center. Now we can connect our 4 points and then finish off by erasing or lightening our center point. Let's look at one more example together. Okay, this equation does look a little bit different, doesn't it? There are no parentheses, and there doesn't even seem to be an h or a k. I want you to try this one on your own, but I will give you a hint. If you had to rewrite this as x minus something squared and y minus something squared, what could you subtract here that wouldn't actually change x or y? Pause the video to think on that and graph the circle now. What can I subtract from something without changing it? Well, that'd be 0. So that means that h is actually 0. And the same thing happens for k. So what will this make the center of the circle? The center is 0, comma 0, or our origin. If the center was the only part of the problem that you were stuck on, pause now and finish it off on your own. For the radius, we know that r squared equals 53. So if we solve for r, we can see that the radius is the square root of 53. This is another case where the radius will not be a whole number, so we're going to need to use the decimal approximation. If I put the square root of 53 in my calculator, I get that it is approximately 7.28011. And for graphing purposes, let's just round this to 7.3. So I will plot my points about 7.3 units away from the center. These points will not be perfect, so just do your best to estimate. Now I can draw in my circle and finally erase or lighten my center. And there's the graph of our circle. We did a lot of examples together today because there are lots of small differences in the standard form circle equation that can change the way it needs to be handled. For every standard form equation, you are always going to want to find h and k to get the center. Be careful about the signs of your coordinates. Remember, the equation is written as x minus h and y minus k. Also, don't forget that 0 is a possible value for h or k. You'll also need to find the radius. If you get a square root of a number that's not a perfect square, you're going to have to use your calculator to get a decimal approximation and estimate the location of each point as best as you can. Good luck on your practice, and I'll see you next time!